Okay, so this question is about probability. So we've been given the probability tree. So Finley plays 2 tennis matches. The probability that he will win and that he will lose are shown in the tree diagram. So first match here, second match here. Question asks us, work out the probability that Finley wins both matches. So that's that he wins the first one and wins the second one. So actually I'm going to go up that first tree like that, so the first branch, and then up the second one. So as I'm going across, to work out the probability that he'll win and then win, I'm going to do 0.7 multiplied by 0.7. So times those two things together, and that gets me 0.49. So my answer to that first question is 0.49. Now, second one, the probability that he loses at least one match. So if he loses at least one match, the outcomes could be he could win the first one and then lose the second one. He could lose the first one, and win the second one, or he could lose both. Now, two different ways I could do this. Either I could work each of these out, so win and then lose and then win, or lose and then lose. Okay, so I could do that. That will get me win and then lose is 0.7 times 0.3, which is 0.21. Lose and then win, 0.3 times 0.7, so 0.21. Lose and then lose, 0.3 times 0.3, which is 0.09. Now, when I add those three together, I get 0.51. Now, the other way I could have done that is I know that these are the three outcomes that are not win and win. So if that's the four possible outcomes, in order to work out these ones, the whole of this must add up to 1. So I could have done 1 minus the 0.49 to get 0.51. So either method would work. Can you use that to try this question? So pause the video and try this question here. Okay, so wins both matches here. We've got 0.4 times 0.4. Which is 0.16. Okay, loses at least one match. We've got the same possible outcome. So win and then lose. 0.4 times 0.6, 0.24. Lose and then win. That one, then that one. So again, 0.6 times 0.4. Lose and lose. 0.6 times 0.6, which is 0.36. So loses at least one match. If I add those together, so 10, 14, 3, 4, 5, 6, 7, 8, 0.84. And I can check because they add up to 1. So 2 marks for each of those. Okay, so within this question here, we're looking at a higher question on circles and area. So the question says, here's a diagram showing a rectangle, A, B, C, D, and a circle. BC is the diameter of the circle. Calculate the percentage of the area of the rectangle that's shaded and give your answer to 1 decimal place. Now, it's important that we do give that to 1 decimal place. If we don't, we won't get all the marks. So what I've got to work out is the area of the shaded region. So the first thing I'm going to do is the area of the rectangle. So the area of the rectangle we know is base times height, which in this case would be 19 multiplied by 16. Now this is a calculated question, so I can do 19 times 16, which is 304 centimetres squared. Okay, now that's the whole rectangle. However, I want to get rid of this part because that bit's not shaded in. That's a semicircle, so that's the area of the semicircle. So that's the next thing I need to work out, the area of the semicircle. So the area of a circle we know is pi r squared. The area of a semicircle will be half of that, so I'm just going to divide it by 2. Now, the radius of this circle. Well, I know that the full length, the diameter, would be the same as this distance, so that's going to be 16. So the radius would be half of that, which is 8. So for the area of the semicircle, I'm going to do pi times 8 squared divided by 2. So 8 squared is 64, so I've got 64 pi over 2. If I do 64 divided by 2, I've got 32 pi centimetres squared. So I've worked out there the area of the rectangle and the area of the semicircle. So I need the area of the shaded region, so that's what I'm going to do next. So the area of the shaded region would be the full rectangle, so 304 minus the semicircle, which is 32 pi. Okay, so I'm going to type that into my calculator, 304 minus 32 pi, and that gets me 203.469. Okay, and that's the area of the shaded region. Now the question's not asking for that area, it's asking for the area as a percentage of the total rectangle. Okay, so that out of the area of the total rectangle. So I'm going to do 203.469, and I'm leaving that on my calculator. So I'm just going to use that number that's there on my calculator, or I can use the answer button. So divide that by the total area, so 304, and then times it by 100, because I want it as a percentage. And then times by 100, and that gets me 66.93. So it's asking for one decimal place, so I've got 66.9%. So can you use that to answer this question here? Okay, so let's go through the answer to this one. So same kind of thing to start off with. The area of the rectangle would be base times height, so 15 times 12, which gets me 180. I then want the area of the semicircle, which would be pi r squared, we said divided by 2, because I only want half the circle. Now in this case, if that's 12, the radius is 6, so I've got pi times 6 squared divided by 2, which is 36 pi divided by 2, which gets me 18 pi. If I get my units on here as well. So the area of the shaded region, so let's just go over there a second. So the shaded region is 180 minus 18 pi, which gets me 123.45 and so on. So again, I want that as a percentage out of the total, so I want that out of 180. So I'm going to leave it on my calculator, divide by 180, and then times by 100, because I want it as a percentage. And that gets me 68.58, which to one decimal place is 68.6%. So this question is about histograms. So if we start from the question, the histogram gives information about house prices in a village in 2015. It's got the x-axis labelled as price in thousands, and the y-axis is labelled as frequency density, but there's no scale given. 20 houses in the village have a price between 300,000 and 400,000. Well, that's going to help us to work out the scale on the y-axis. Work out the number of houses in the village with a price under 200,000. Now, frequency density, first thing. We know that frequency density, to work that out, you're going to do frequency divided by the class width. Okay, so in this case, to work out the frequency density, we know that whatever this is going to be frequency, which is 20, divided by the class width, which is 100, because the difference between 300 and 400 is 100. Okay, so the frequency density is going to equal frequency divided by the class width. 20 divided by 100, which is the same as 2 over 10, okay, which is 0.2. So I know that at this line here, it's 0.2, and I can write that scale on. Now that's going to help me, because then this one, follow that across, would be 0.1. So each of these big boxes is 0.1. So it goes up to 0.1, 2, 3, 4, 5, 6, 7, 0.8 there. So the question's asking how many, the number of houses in the village with a price under 200,000. So I've been asked for anything within this, so the area of each of these three bars, the first one, the second one, and the third one. So the area of that first bar, well, if that's 0.1, it will go up to 0.14. Okay, so the frequency is the area of the bar. So I'm going to do base times height, which is 100 times 0.14 for that first bar. Second bar, the width is 50 and the height is 0.6. And then the third one, width again is 50 and the height is 0.8. So I'm going to type those into my calculator. 100 times 0.14 will 14, 30 and 40. So I need a total 84. So the total number of houses is 84. So use that to answer the question underneath. So same kind of question, but this time we've got 30 houses between 300 and 400,000. So frequency density is frequency divided by the class width, which here is 100 again. So 30 divided by 10, which is 0.3. So I've got that as 0.3, so every two boxes is 0.3. So I've got 0.6, 0.9, and then 1.2. So again, if I've been asked for the area of those first three, so the first one, the width is 100 times the height, so I've got there 0.15, and each box will be 0.015, so 0.18. Okay, and then that second one I've got 50 times by 0.9, and then the third one 50 times 1.2. Okay, so if I type those in, I've got 18, 45 and 60. So add those up, 123. So again with this one, because of this part here, the scale's really small here. So if you're a few either side of that, that's fine. So if you're anything between 115 and 130, you get those marks there, as long as you've shown that working out. So in this question, it's about averages. So Walkden Reds is a basketball team. At the end of 11 games, their mean score was 33 points. At the end of 10 games, their mean score was 2 points higher. Jordan says that they must have scored 13 points in their 11th game. Is he right? So in order to work out the total score after 11 games, in order to work out the mean, you do total divided by the number of games they've scored, and that gets you the mean. So in this case, we've got total divided by 11 games, and the mean is 33. So in order to work out the total, I'm going to do 33 times by 11, and that gets me 363. So the total points from 11 games was 363. At the end of 10 games, the mean score was 2 points higher. So at the end of 10 games, the mean score was 2 points higher than that, so 35. So the total point at the end of 5 games was 35 times 10, which is 350. Okay, so at the end of 10 games, he had 350 points. At the end of 11 games, he had 363 points. So to work out how many points they scored, 363 minus 350, 13. So is Jordan right? Yes, he is. Using that, can you answer this question here? Okay, so at the end of 12 games, the mean score was 28. So something divided by 12 gets me 28. So to work that something out, I'm going to do 28 multiplied by 12, 336. So at the end of 12 games, they had 336 points. At the end of 13 games, their mean score was 1 point higher. So something divided by 13, 1 point higher than 28, 29. So 29 times by the 13 to get the total, 377. Okay, 377. So to work out the number of points in that last game, I'm going to do 377 minus 336. 41 points they must have scored in that last game, so must be false. No, cannot be correct. So in this question, we've got to solve an equation that involves two fractions. So algebraic fractions here, we need to find first a common denominator. So common denominator, lowest common multiple of 3x and 2x is going to be 6x. So I'm going to use 6x as my denominator. Now, first fraction, to get from 3x to 6x, I multiply by 2. So I've got to multiply the numerator by 2 also. Second fraction, to get from 2x to 6x, I times by 3. So I've got to multiply the numerator by 3 also. So that leaves me with all over 6x is equal to 3. So I've just tidied that up a little bit. So in order to get rid of the divide by 6x, I can times both sides by 6x. And that gets me 2x plus 2 plus 3x minus 2 equals 18x. Okay, so I'm now going to expand the brackets. 2x plus 4 plus 3x minus 6 equals 18x. Okay, and simplify this, so I've got 5x minus 2 equals 18x. So I'm now going to solve. So I'm going to minus the 5x from both sides. So I've got minus 2 equals 13x. Okay, and then divide both sides by 13 to leave x on its own. So I've got minus 2 over 13 is equal to x. And I'm going to leave it like that, leave it as a fraction. Okay, so that there is my answer. So using the same method, try this one. So first thing I'm going to do, look for a common denominator again, which is 6x. So multiply this one, or both these parts of this fraction, numerator and denominator, by 3. So I've got over 6x, and the other fraction by 2. Equals 5. Okay, so then tidy that up a little bit. All over 6x is equal to 5. So now I can multiply both sides by the 6x. So I've got 3x plus 3 plus 2x plus 4 is equal to 30x. Okay, so I've now got, if I expand the brackets, 3x plus 9 plus 2x plus 8 equals 30x. 3x plus 2x gets me 5x, 9 plus 8 is 17. Okay, so if I'm now solving that, I'm going to minus the 5x from both sides, leave the 17 where it is at that point. So I've got 17 equals 25x, and to get from 25x to x, I've got to divide by 25. So I'm left with 17 over 25, and that there again I would leave as my answer.